cases rather than just the total number of concordant and discordant pairs like in gamma. Tau c can be used when the table is not a squared contingency, in other words 3 by 5 or something like that. Okay, don't worry too much about all of these measures of strength, because you're going to be reading them rather than figuring them in SPSS. Which one do we use? Well, don't forget, we talked about this. Gamma is influenced by the number of columns and rows. The less columns and rows, the higher the gamma. Therefore, tau b and tau c are a more robust test of strength of association for ordinal variables, okay? And these are the things that you need to know, so you take notes and keep these in your notebook. In picking the best measure of association to use, first ask yourself what level of measurement you're dealing with, okay? And if one or both variables are nominal, use Cramer's V. If both are ordinal, use tau b. If the table contains equal numbers of rows and columns, or gamma, or tau c otherwise, okay? So if one variable is nominal and the other one is ordinal, what are you going to use? Cramer's V. Got it. All right. Other measures of strength that you might use, pardon me, are lambda, which is for squared contingency tables, and they're for nominal to nominal. And of course, if you're going to use nominal variables, this is the one that you want. And asymmetrical, it's an asymmetrical measure, and it varies between 0 and 1. It compares errors in prediction when the IV is used to predict the DV. Okay, so independent variable is used to predict the dependent variable. Okay, the odds ratio is something different, that as we go on, we're also going to be using the odds ratio in logistic regression. It's another form of relationships. But 2 by 2, so use that in a 2 by 2 table, and it's used to estimate probabilities that individuals will belong to group B given that they belong to group A. Okay, so they're not mutually exclusive. And then the relative improvement over chance, or RIOC, is a probability of a hit versus a miss, and a contingency coefficient is the same as Cramer's V, but it's influenced by the size of the table. Okay, now that I've told you about those, you could go ahead and forget them for now. And here's the approximate standards for interpreting the strength of an association. So if I'm using gamma or Cramer's V or phi, if it's greater than 0.50, it's a very strong association. If it's 30 to 0.30 to 0.50, it's a moderate association. If it's running between 0.10 to 0.3, it's a weak association, and from 0 to 0.1 is no association, okay, or a very weak association. So again, another summary. For a 2 by 2 table, we're going to use phi, 2 nominal variables, but the table is bigger than 2 by 2, we're going to use Cramer's V. If the ordinal, if one ordinal and one nominal, we're going to use Cramer's V. If both variables are ordinal, if the table contains equal numbers of rows and columns, we're going to use Kendall's tau b or gamma. And if the table does not contain equal numbers of rows, we're going to run tau c. Okay, and gamma equals tau b, except tau b is more robust. Okay, so measuring the strength of association, again, between two nominal or ordinal variables. Here's the summary. Phi is for 2 by 2 tables. It ranges between 0 and 1. Cramer's V is n by m tables with nominal variables ranging between 0 and 1. Gamma is for squared contingency tables with ordinal variables. It ranges between -1 and +1. The tau b is for squared contingency tables with ordinal variables, and it also ranges between -1 and +1. And tau c is for n by m tables, what I'm saying is not squared contingency tables, with ordinal variables. Okay, it ranges between -1 and +1. So in a 2 by 2 table, we're going to use Kramer phi equals Kramer's v. They're both the same. So that's an important thing to remember. Let's recap. The chi-square test is used to assess whether there's a significant association between two nominal, name, or ordinal variables. Okay, the null hypothesis means that there's no relationship between those variables. Chi-square does not provide the info on strength of the association. For that, you need phi, Kramer's v, gamma, tau b, or tau c, and they're the most commonly used measures of strength between the variables. And all these tests demonstrate whether there is a significant association between the variable, but not which is the cause of the other. That's an important thing to remember. In summary, to assess the relationship between two nominal or ordinal variables, we're going to compute the value of chi-square. If the chi-square is not statistically significant, the variables are independent. Okay, that is, that there's no association between them, and the analysis just stops. If, on the other hand, chi-square is statistically significant, you measure the strength of the association, and you present the results in percentages, and you offer an interpretation of the results. You interpret the percents. Okay, here's a reminder. When we're reporting a chi-square test, there is a significant association between good looks and success. Okay, that's an example. There is a statistically significant difference between the proportion of good-looking people, and we did this in the first set of lectures. There is a statistically significant difference between the proportion of good-looking people who are successful versus the proportion of ugly people who are successful. Okay, and you remember we found that chi-square equals 31.7, the degree of freedom equaled 1, and p was less than 0.001, which means what? It means that I have a 99% chance of being correct, all right? And the relationship between these two variables is weak because the phi value was only 0.10, all right? Findings show that 88% and 35 of good-looking people are not successful, in contrast to only 25% of ugly people. Among those who are successful, 14% are good-looking. 75% of ugly people are good-looking. So then you would go ahead and offer some possible explanations for these results. Here's some review questions. Question. The chi-square test is used to determine whether there is a significant relationship between variables that are what? Ratio or interval? Interval or ordinal? Ordinal or nominal? Or nominal or ratio? All right, let's see if you get this one. What's the answer? That's right, it's ordinal or nominal. Okay, next review question is the chi-square statistic is a measure of the strength of the association between two variables. True or false? That's right, it's false. The chi-square statistic simply indicates whether there is a significant relationship between the variables. Okay, here's another question. What does it mean if the p-value for the chi-square statistic is less than 0.05? It means that you can reject the null hypothesis. All right, there is a significant association between the variables. It means that there's less than a 5% chance that these results are due to error or randomness. Okay, another question is, what does it mean if the chi-square statistic is not statistically significant? In other words, p is greater than 0.05. Remember? It means that we fail to reject the null hypothesis. Your variables are independent from one another. Okay, it means that there is no significant association between your variables. Another question is you look at the relationship between gender, male and female, and drug use, yes or no. State the null and alternative hypotheses. Okay, the answer? Go ahead, tell me. That's right. The null hypothesis is there is no relationship between gender and drug use, meaning that being a male or a female is not linked to whether you use drugs or not, as opposed to the alternative hypothesis, which means that there is a relationship between gender and drug use. Being a male or a female is linked to whether you use drugs or not. Here's another question. What coefficient of strength of association would you report if you're looking to the relationship between gender, male and female, and drug use? Yes or no? Which one is it? Remember? Yes, that's right. It's phi. Why? Because it's a 2x2 table. The next question is, what coefficient of strength of association would you report if you're looking at the relationship between gender and income? Why, we'd use Cramer's V. Why? Because one variable is nominal and one is ordinal. And another question is, what coefficient of strength of association would you report if you're looking at the relationship between behavior in prison among inmates, bad, average, and excellent, and success in obtaining parole? Not successful, somewhat successful, and very successful. What would you use? Do you remember? That's right. You'd use either tau b or gamma. Why? Because they are both ordinal variables, and the table has an equal number of rows and columns. It's 3x3 in this case. And another review question is, what coefficient of strength of association will you report if you are looking at the relationship between success in obtaining parole, not successful, somewhat, and very, and opinions of the death penalty? Strongly agree, disagree, and strongly disagree. What would we use? That's right, we'd use, remember, tau c. Why? Because they're both ordinal variables and the table does not have an equal number of rows and columns. It's a 3x4 table. Another is you should always report the strength of association between your variables, even if the relationship is not statistically significant. True or false? That's absolutely correct. False. If the chi-square is not statistically significant, the variables are independent. That is, there's no association between them. The analysis stops right then and there, and there's no need to report the strength of association between the variables. You already know it'll be weak. And that concludes part 2 of the chi-square lecture. So I hope that you have absorbed the strength of associations and all the ones that we would use for different categories, and you understand when we use chi-square. If you have any questions, please go ahead and post them on the board, and if you understand the material pretty well, please also post that on the board. And I'll see you next week.